All right, Pre-Calc Unit 1, Lesson 2. The word of the day for this lesson is functions. All right. So a function is when we're talking about like sets of numbers. And so it's kind of a relationship between two sets of numbers. So I like to think about it as like a function machine where we have our inputs. And then something crazy happens, there could be an equation, there could be something, there's some type of operation going on, and then we have our outputs. Okay? So in order for it to be a function, each input, okay, so no matter what it is, if it's A, B, C, okay, they have to have their own unique output. So if we have an input, it's got to come out to its own kind of result. So maybe this is a 2, maybe we have a 3 and a 5. So for example, if I input A into my function machine, I get out a 3. If I input C into my function machine, I get a 2. If I input a B, I get a 5. For each input, I have a different output. Now, it is okay if you have different inputs. So let's say I put a D in here, but my output is still a C, is still 2. That's okay because I have different inputs. Where we get into trouble is if I say, hey, I inputted an A and I got a 3. I input a B and I got a 3. Check, excuse me. I input an A, I got a 3. I input an A, and this time I got a 5. So if we input the same thing and we get a different answer, that is not good, okay? If we input an A, we should always get the same answer. If we're getting two different answers, it is then not a function. So again, here's kind of a more realistic, concrete example. Let's say that I have the time of day, okay? Time of day. And then my function machine, bloop, 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 okay, something's happening. And then the corresponding thing is the temperature of the day. So let's say at 1 o'clock, it is 50 degrees, okay? At 4 o'clock, let's say that it's 60 degrees. And then at 5 o'clock, it is 65 degrees. However, when it starts getting towards the nighttime, it starts cooling off again. So let's say at 9 o'clock, it goes back to 50 degrees. That's okay, all right? That is okay for us to have. The problem would be is that if we input, hey, at 1 o'clock it was 50, and then the next day at 1 o'clock it was 52, that would not be a function, okay? Because again, if we were to graph it, so let's say, hey, X is 1 and I got 50, but then I did it again and I got X is 1, but Y was 55, they're stacked on top of each other, okay? So we call this the vertical line test. So because again, if I were to graph it, these data points would be stacked on top of each other. It would fail the vertical line test, okay? So if it's a function, for every input, you should get a different output, okay? There should never be data stacked on top of each other. So each element of A must be matched with an element of B. So for every input, we have to have an output. Some elements of B may not be matched, okay? You may have other numbers out here. 82, 33. That's okay, okay? We don't need to have necessarily an input for an output. However, every input needs to have an output. Like we said, you can match, if you have different inputs, they can have the same output, but the problem is when your input gives you two different answers. Input gives us two different answers. That is not a function, okay? That's when we get in trouble. When we get one input, but we get two different answers. So let's look at a table. Let's look at a table here. So I'm going to draw my inputs and my outputs. I'm going to say, again, my inputs are like my x coordinates. My output is like my y. And I'm going to say that I get an input of 2, an output of 11, an input of 3, an output of 10, an input of 4, an output of 5. And then I'm going to go back. I'm going to say an input of 3, an output of 10, and then an input of 2, output of 10. So I see I've got a couple inputs that repeat. But if I look, it repeats and I get the same thing. That's okay. That's what we want. However, when I look at my input of 2, I see that I get an output of 11 and I get an output of 10. So I'm going to say not a function. And it's because of these ones right here. Okay? That is what makes it not a function. Again, like I was kind of describing, we can do something called like the vertical line test, where if I were to take my pencil and just move it from left to right, straight up and straight down, again, I'm like, I'm good here, 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 I'm good here. Nothing is touching twice. Nothing is overlapping. So we could call, again, if you get a graph, yes, this would be a function because it passes the vertical line test. So again, oftentimes we're going to have to test out whether these are input, like whether these are functions or not. And sometimes you might have to do some work, okay? So it might not come super cookie cutter, nice and neat. For example, you might get something like x squared plus y equals 1, okay? This is difficult for us to graph because it's not in the y equals form. We like things to be in y equals. So all I'd have to do is subtract x squared on both sides of my equation. And I'm left with y equals 1 subtract x squared. Now, there's a couple ways I could solve this, okay? I could try and plug in table of values. So I could give myself an x coordinate and then figure out what my y coordinate is, maybe -2, -1, 0, 1, and 2, okay? And I would just plug those x's in. So I would do, what's -2 squared? What's 1 minus -2 squared? What's 1 minus -1 squared? What's 1 minus 0 squared? And I would record those values. Or we can graph it. Come on, Desmos. So I'm going to type in y equals 1 subtract, let's see here, x and squared, okay? Now I can use my vertical line test and say, oh yeah, I can see I am not touching any point more than once. Therefore, I can conclude that this is a function, okay? I would recommend, again, if you don't have this app downloaded, get this Desmos app. We will have to use it for graphing purposes. Just to clear up some like vocab stuff, okay, function notation. If our inputs are x, our outputs are f of x, the function of x, okay? This is called function notation. So again, here I used y equals. As we move forward in math and as you keep climbing to higher levels of math, you're going to start using f of x. It basically means y, but again, it's not y, it's the function of x equals 1 minus x squared, okay? So when you see f of x, you can kind of think of it like y equals, if that's what you're more comfortable with. However, just know that this is called function notation. All right, so let's go ahead and evaluate a function. So let's take our function. Again, it doesn't always have to be f of x. It can be g of x, z of x, whatever. Okay, so our function that we're going to use is g of x equals negative x squared plus 4x plus 1. And I want to find, let's check 3 different ones. Okay, so let's check g of 2. Let's do that one first before we write the other ones, okay? So every time I see an x, I'm going to substitute a positive 2. So always write it out first, okay? Always write it out first. PEMDAS tells me to do exponents first, so 2 squared is 4. So g of 2 equals negative 4 plus 4 times 2 is 8, and I still have plus 1 at the end. Negative 4 plus 8 equals 4, and then I still have a plus 1. Therefore, g of 2 equals 5. Okay, let's try a different one. This one is, again, slightly different. You may have a value for t. So like if you get something like g of t, you may have to plug in whatever t is, you got to plug it in. So negative t squared, okay, plus 4t plus 1. And because I don't know what t is, right, this isn't a variable, this is unknown, I can't solve the problem. Now, if they told me what t was, I could plug it in. But unfortunately, I don't know. And then again, this is kind of building up to where we want to get to. Part C, you might get the function of x plus 2. So every time I see an x, I'm not just going to put a 2 in there. I'm going to plug in an x plus 2. Okay, for x plus 2 plus 1. Now we can do some simplifying. This is going to be a little bit more work though, because I have a negative, and because it's x plus 2, remember, the whole thing is squared. So I have to rewrite the whole thing. So I'm going to, because a square means you multiply it by itself. So that means I have to take x plus 2 and multiply it by x plus 2. So remember, you take x, your first term, and you multiply it, you multiply it into your first term in your other parentheses, and you multiply it into the second term. And then I'm going to take my second term in my parentheses here and multiply it into each term. So let's do that step by step. So x times x, don't forget, we still have this negative out here, and we'll kind of deal with that later. Okay, so let's see here. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. So I got to first think, do I have any like terms? Yes, I do. I have a 2x and a 2x. So I still have this negative out here. I'm going to say x squared plus 4x plus 4. And then I got to remember to bring this down as well, because I haven't finished that. 4x plus 2 plus 1. Now, it's just like we did with our foiling up top, this negative, it's like a negative 1, right? Negative 1. We have to multiply it into each term. So if I rewrite this, it's actually going to be negative x squared minus 4x minus 4. And let's go ahead and FOIL this. So this is 4 times x, 4 times 2. So plus 4x plus 8 plus 1. Now, I bet we have some like terms. I see I have an 4x right here, and I have a negative 4x. Interesting. Something should be going on in your head. I have a negative 4, a positive 8, and a positive 1. So as I simplify, I still have negative x squared. Negative 4x plus positive 4 cancels out. So that goes away. And then we have negative 4 plus 8 is 4, and 4 plus 1 is 5. So the function g of x plus 2 equals negative x squared plus 5. All right, let's take a look at piecewise functions, okay? Piecewise functions are functions that are defined by 2 or more equations over a specific domain. So you might use a function for when x is bigger than 0, and then you might use a different function for when x is smaller than 0. So for example, f of x, function of x, equals x squared plus 1 when x is less than 0. And then I want to use x subtract 1 when x is greater than or equal to 0. So the question we're going to solve is evaluate f of x, the function of x, when x equals negative 1 and when x equals 0. So my first one, negative 1, I got to decide, am I going to use this top equation or am I going to use this bottom equation? Well, I know that negative 1 is less than 0, so I'm going to use equation number 1 for my first one. So f of negative 1 equals, and every time I see an x, I'm going to plug in a negative 1. Negative 1 squared plus 1. Negative 1 times negative 1 is positive 1, and 1 plus 1 equals 2. So the function of negative 1 equals 2. Now, I got to think, I've got x equals 0. Well, that's going to be this one because x is greater than or equal to 0, so I have to use equation 2. And I know that I can plug in a 0 for x. This one's going to be pretty easy to solve. 0 take away 1 equals negative 1. So again, we got 2 different answers, and we had to use 2 different equations for that one. All right, so the domain of a function can be described explicitly, or it can be implied by the expression used to define the function. The implied domain, so if it doesn't specify specifically, is all real numbers. However, the caveat is that we can't, sometimes there are numbers that aren't real. So for example, f of x equals 1 divided by x squared minus 4. You cannot have a denominator equal to 0, okay? That's undefined. We can't do that in math. So it becomes a non-real number. So think about this. If I had an x, the function of 2 or the function of negative 2, and I plug those in, okay, I'm going to end up with 1 over 0 and 1 over 0. So we would say that the domain for this is all real numbers, okay? So all reals, this is the real number symbol, except or excluding, okay, except for 2 and negative 2. So any number besides x equals 2 or negative 2 would work for this problem. But if we get 2 or negative 2, that's going to screw up our problem. Another really common example is if you have a square root symbol, okay? So let's look at f of x equals the square root of x. In this case, we can't ever get the square root of a negative number because think about it. The definition of a square root is a number multiplied by itself. And if you take a negative multiplied by a negative, you will always, always, always get a positive. So for this, the domain, okay, has to be x is greater than 0 because any number that's smaller than 0, okay, is going to be negative, and we can't take a negative number. So there's a couple ways. That's one way to write it. Another way to write your domain, it's called interval notation. So again, brackets mean it can equal it. So if you use a bracket, that means yes, it can equal 0. And we want to go all the way up to infinity. But here's the thing. Can we ever reach infinity? No, you cannot. So we have to use a parentheses. So to reiterate, a bracket means inclusive, okay? It includes it. A parentheses exclusive does not. So again, we obviously could never reach infinity, so we can't include infinity. So let's see here. Let's just do an example, a couple examples real quick. So if I were to look at h of x and I said, find the domain, and I gave you 1 over x plus 5, you would think right away, what number would make our denominator equal to 0, okay? So our denominator cannot equal 0. Well, that would be negative 5, right? Negative 5 plus 5 equals 0. So I could say that our domain is from negative infinity all the way to negative 5, but it can't equal negative 5. It could be negative 0.50000000001. That'd be okay. It could be negative 4.999999999. That'd be okay. But we can't include that negative 5 in our answer. And then, of course, we would want to include negative 5 all the way to positive infinity. So that's one way you could say all reals except x equals negative 5. Just a couple different ways to write it out. And so let's see here. Another way you can find the domain. So again, your domain is kind of like your x coordinates. Your range is your y coordinates. So if I'm looking at the function, I'm going to use my calculator here, of the square root of 9 subtract x squared. Okay, I'm going to plug that into my calculator. Square root of 9 subtract x squared. All right, if this is what it looks like, so I can say, negative 2, this is going to be negative 3, and then negative 4. So it looks like my x coordinates go all the way from negative 3 to positive 3. So I'm going to say, okay, my domain. So my domain is from, it can't be negative 3, and it can't be positive 3, but it can be any number in between. Now let's take a look at our range. So again, the range tells me I'm looking at the y coordinates. So it looks like this number never goes below 0. So our y value never gets below 0, and it looks like it tops out at 3. So I would say that our range would be from 0 to positive 3, because that's where our graph ends. Okay, let's see here. Couple more examples. Let's do a baseball example. So I'm going to say that a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given the function f of x equals negative 0.0032 x squared plus x plus 3. Y and x are measured in feet. The question is, will the baseball clear a 10-foot fence located 300 feet from home plate? So I need my result. So again, the question is saying, hey, if x is how far I hit it, x is how far, and y is how high. So I'm thinking I need my final answer, okay? I need f of x to be greater than 10, and I need my x to equal 300 because that's how far the fence is. So we're going to rewrite this problem, and we're going to plug in our numbers, okay? So I'm going to plug in, let's see here, we can use green. F of 300 equals negative 0.0032 300 squared plus 300 plus 3. Now again, you probably don't want to do that in your head, so we can use our calculator. Let's use this one. So again, this is like f of x or y equals negative. Got to make sure I use the correct negative sign. I'm also getting used to this calculator. Well, we'll try this. This is subtraction. We'll see if it works. Negative 0. I already forgot the number. 0032. 0032 parentheses 300, close my parentheses, squared, plus 300 plus 3 equals, oops, it already had told me, okay? So it says it equals y equals 15. So that's why we like calculators, because I didn't have to go through all of this. So let's think. F of 300 equals 15. Going back to the original question, will the baseball clear a 10-foot fence located 300 feet from home plate? Well, we just proved, hey, at 300 feet, the baseball, according to this equation right here, will be 15 feet high. So the answer is yes. Home run. Go Twins. Okay. I know these are a lot of examples. I've got one more example to go through, and then you guys will have some time to practice. Okay, so this is kind of like a difference quotient. So evaluating a difference quotient, excuse me. So we're going to use the function f of x equals x squared, subtract 4x plus 7. And what I want you to find is find f of x plus h, subtract f of x, and then divide it by h. This is kind of a common equation. Again, this is something that is done a lot. So again, I want you to kind of look at this. F of x plus h, take away f of x, and then divide it all by h. So this is going to be a lot of writing out. So every time I see x, I'm going to write x plus h. So let's start, okay? So I'm going to say f of x plus h minus f of x divided by h equals, every time I see an x in this equation right here, I'm going to write x plus h. So let's get a different color. So every time I see an x, I'm going to write x plus h squared. So I'm just on that first term. Minus 4. Oh, there's another x. So I got to do x plus h plus 7. No h yet. Okay, so this part's done. Now let's jump to subtract. Okay, so, oops, let's use pink. Subtract, and make sure that you are careful. Let's use parentheses here. Now this right here is the same as this. So I'm just going to plug in x squared minus 4x plus 7. And then I have to divide it by h. I don't know what h is yet, so I'm just going to use h right here. All right, let's start simplifying. So equals, first things first, x plus h squared. I got to do some side work, okay? Anything squared means multiplied by itself, and then you have to FOIL it. Okay, so I'm going to multiply the first term by the first and the second term in my second parentheses. So x times x is x squared. X times h is xh. H times x is hx, but you can write it as xh again, okay? Because does the order of multiplication matter? No, it doesn't, okay? So xh or hx, again, 2 times 3 or 3 times 2 is going to give you the same exact answer. And then h times h is h squared. All right, so that gets us done with that one. Now we got to move over here. Negative 4 times x is negative 4x. Don't forget, this negative right here is included in the 4, okay? Negative 4 times h is negative 4h plus 7. Oh boy, gonna run out of room. Let's see if I can pick this up and move it. Oh man, look at that. Isn't that cool? All right. Now I got to do this pink section. So again, this negative is applied to every term inside my parentheses. So subtract x squared. Negative times negative is positive 4x. Negative times positive is negative 7. This is why it's super important to show all your work, because we got a lot of things going on here. All right, let's highlight some things that potentially could cancel out. So I see x squared or simplify. Do I have another x squared? Yes, I do. And look at that. It's a negative x squared. So if I take x squared minus x squared, guess what? Cancels out. Boom. I see I have an xh. Let's get a different color. I've got an xh here, and I have an xh here. So if we're simplifying this, we're going to call this 2xh. 2 times xh. Okay, let's keep going. I see negative 4x and positive 4x. Negative 4x plus positive 4x cancels out. So again, what you should be noticing is, hey, if I'm doing this correctly, there's a lot of stuff that's canceling out. Boom, boom. So now I only have negative 4h and h squared. So I'm going to say plus h squared minus 4h. And we can't forget about this guy all the way down here. Okay. Now, I want you to look at each term on the top. Is there something in common that each term has? Hopefully you see, hey, they all have h's. So what we're going to do is we're going to factor out an h from each term. So if I divide an h out of each one, I'm going to be left with 2x plus h minus 4. And then I still have this h on the bottom. Now, so hopefully you guys are seeing, hey, if I have an h on the top and an h on the bottom, think about any type of division. 2 divided by 2 cancels out. 5 divided by 5 cancels out. H divided by h cancels out. So what I'm left with is 2x plus h minus 4. And h cannot equal 0, okay? H cannot equal 0. So that's going to be your final answer. That was a lot. That was tough. Okay, again, tips to be successful. You have to be organized. You have to take your time. You have to go step by step. You can't jump around. You can't take shortcuts.